My name is Avi Loeb, and for more than 4 decades I've studied the sky with a mixture of humility and stubborn curiosity. But nothing, absolutely nothing in my career prepared me for the moment I saw the first anomalous data stream from an object now known across every observatory on Earth as 3I/ATLAS. At the time, it was just another distant blip rolling across the solar system, faint and slow, almost forgettable. Scientists logged it, catalogued it, moved on, but there was something in the numbers, something quiet, almost shy, like a whisper from the dark. Not wrong, just misaligned, off by a breath, the kind of deviation that tells you nature is preparing a trick. And nature, as I later learned, was only the facade. I remember the night the alert arrived. The control room at the observatory in Chile buzzed with the usual hum, the steady churn of machines, the low murmur of astronomers half convinced they could tame the universe with enough coffee and code. I stood behind a cluster of researchers examining 3I/ATLAS's trajectory, projected as a thin white arc looping toward the sun. It was a standard inbound track, the kind you forget in minutes because thousands like it drift through our system every year. Then one of the analysts murmured something that froze the room. "It's brightening too fast." Too fast. That phrase devours astronomers. Natural processes follow predictable rules. Thermal gradients, volatile release, sublimation curves. But 3I/ATLAS was brightening at 7.5 times the expected rate, like someone had turned up a cosmic dimmer switch in a single motion. The images came in, pixels sharpening into an irregular, shimmering form, bathed in an electric blue halo. Blue, not red like frozen bodies reflecting solar heat, bluer than the sun. I leaned in so close my breath fogged the glass. "That's impossible," one of the senior NASA advisors whispered. "Nothing that cold should scatter blue light like that." I wanted to agree. Instead, I felt something else stirring, a strange exhilaration, like standing on the edge of a revelation. By dawn, every observatory was locked onto it. Telescopes pivoted in unison across continents. 3I/ATLAS was no longer forgettable. It was a trespasser from another star system, making its first recorded visit to ours. If the object behaved predictably, it would swing around the sun, lose mass, shed vapor, and arc back into deep space on a fading trajectory. But predictability died on October 29th. That was the day we watched the universe break character. I was on a video call with colleagues from NASA's Jet Propulsion Laboratory. On the main screen, a 3D model of the object spiraled inward toward the sun's gravitational well. The sunlight flared behind it in a golden corona. Everything was in place. Everything matched the models. And then the numbers tumbled. The acceleration vector shifted, slightly at first, almost dismissible. Then again and again. A subtle twitch, a correction, a course adjustment so delicate it would have escaped us if not for the sun's fiery backdrop. One of the engineers swore under his breath. "It's steering." The room fell silent. Gravity doesn't simply lose its hold. Objects don't decide to resist star-induced decay. And yet, data from JPL's instruments displayed a clean, undeniable signature, non-gravitational acceleration, as if something inside 3I/ATLAS had come alive. The energy plot spiked, its luminous halo condensed into a sharp electric outline, like an engine core responding to orders. The trajectory line bent, not away from the sun in a lazy thermal drift, but in a controlled arc. A maneuver, no ambiguity, no miscalculation. A maneuver so crisp it mocked every natural explanation we tried to force upon it. I heard my own voice before I realized I was speaking. "This object is not behaving like a comet," someone countered immediately, too quickly. "Rocket effect, sublimation jets, volatiles blasting off the surface." I shook my head. "Not at this angle, not at this magnitude, and certainly not that fast." But the resistance was predictable. Academia bends toward caution. No one wants to be the first to point at the sky and shout that the gods are moving. As the object whipped around the sun, its tail did something so bizarre it felt choreographed. Instead of trailing behind, it flipped forward, forming a thin, luminous spear aimed directly at the sun, a perfect anti-tail, the kind observed only in rare, extreme geometries. But this one wasn't geometric. This one was thrust-aligned. It pointed exactly where a propulsion system would exhaust if reversing momentum to slingshot around a star. Half the room recoiled. The other half argued louder. And I felt the same thing I felt years ago with Oumuamua, an uncanny echo of intentional motion. A voice in the data saying, "Watch carefully, we're not here by accident." When the object cleared perihelion and swung outward, it shed the anti-tail like an actor dropping a disguise. The tail snapped behind it again, conventional, ordinary, almost as if to blend in. But the damage was done. It had exposed a crack in the masquerade. The second anomaly arrived moments later. The chemical analysis updated with a composition unlike most interstellar debris: nickel and high-density carbon monoxide, a combination more reminiscent of engineered alloys and compressed fuels than frozen cosmic stone. One scientist muttered that maybe ATLAS had scraped against a metallic asteroid. Another suggested spectrographic contamination. Another coughed loudly enough to signal discomfort. I simply stared at the readouts. Nickel and CO2, high reflectivity, extreme mass loss, electric blue ionization, a thrust vector of unknown origin. If this had been a laboratory experiment, I would have sworn someone had built the object intentionally. The final blow to natural explanations hit when a JPL tech zoomed in on the trajectory arc. He highlighted 3 faint loops, barely detectable corrections, that aligned the object past 3 separate planets, grazing their gravitational boundaries like pit stops on a voyage. No random cosmic rock follows a path like that. No natural debris makes micro adjustments during a solar flyby. A veteran astronomer, white-haired and tired, turned toward me. "You're thinking what I'm thinking," he said. "I'm thinking," I replied, "that this is our 3rd interstellar visitor in history, and it is the first one acting like an explorer." Outside the window, the night sky sprawled across the Chilean desert. Quiet, ancient, indifferent. But something out there had just blinked back. And for the first time since humanity learned to look upward, a part of me wondered if we had been noticed. The Daily Mail broke the story before dawn. They plastered it with sensational headlines: alien craft, breakthrough evidence, intentional maneuvering, and the public devoured every word. NASA, of course, countered with calm, measured statements: likely cometary behavior, natural outgassing, no indication of artificial origin. But I felt the war beginning, the same war I fought with Oumuamua, the same resistance to uncomfortable possibilities. Scientists aren't afraid of the unknown. They're afraid of ridicule. But ridicule never stopped the universe from telling the truth. As the hours passed, I sank deeper into the data, watching 3I/ATLAS drift farther from the sun, leaving behind a wake of contradictions. The anomalies stacked like clues in a cosmic detective story, a story whose protagonist wasn't human, and whose motives remained locked behind a silence older than our species. But silence does not mean absence. And 3I/ATLAS was speaking in its own way, through every deviation, every impossible burst of acceleration, every defiant flash of blue light. The message, whatever it was, had only just begun. The following 48 hours felt like standing inside a pressure chamber, each new data pulse tightening the walls. 3I/ATLAS was now racing away from the sun, but instead of fading like all comets do after perihelion, it grew brighter, as if energized by its close encounter. Telescopes tracked its glowing blue aura, stretching like a neon ember across the darkness. Every instrument screamed the same truth. Whatever it shed near the sun, it wasn't ice. It was something far more volatile, far more deliberate. At Harvard, I walked into the Astrophysics Center to find screens frozen on trajectory maps, spectral curves, and rotational models. Graduate students whispered in huddles while senior researchers debated in tight circles. The tension wasn't fear, it was denial clashing with dawning certainty. I watched their faces as new photometric readings arrived. The brightness curve shot upward at a slope unnatural for any object cooling after solar exposure. An engineer leaned back in his chair. It's gaining luminosity while moving away from the thermal source. That's backwards. Backwards and intentional. A news notification flashed across one of the screens. Cameras zoomed onto a panel of NASA spokespeople assuring the public that all known data aligned with cometary behavior, thermal jets, outgassing, standard physics. But their expressions betrayed a faint tremor. They had seen the acceleration signatures. They had watched the thrust vectors. They had graphed the anti-tail. Yet they chose caution, not revelation. In the hallway, one of my colleagues caught up to me. Avi, you need to stop pushing the artificial hypothesis publicly. It's making people uneasy. I paused. Truth doesn't depend on comfort. It depends on evidence. We have 9 anomalies. He lowered his voice. 9 anomalies don't make an alien ship. No, I said, but they make one hell of a question. Hell of... Later that night, I sat alone in my office, reviewing the high-resolution footage from the sun-facing telescopes. The screen flickered, showing 3IATLAS approaching perihelion. Even in grainy frames, the object pulsated, a cyan heartbeat in the void. Then came the fraction of a moment that had shattered natural explanations, the flash of light, the shift of motion, the crisp lateral push. I replayed the sequence again and again, slower each time, watching for anything that might hint at mundane physics. A dust jet, a gas plume, a reflective artifact, but natural jets create chaotic motions, spirals, tumble patterns. This maneuver was razor straight, like something executing a programmed instruction. I leaned forward. What are you? Outside, the night over Cambridge glimmered with city lights, unaware that above them a visitor was breaking the rules of physics, one anomaly at a time. Around midnight, a message pinged, a private link from a colleague working with European observatories. New spectral data. I opened it immediately. Dozens of lines of chemical signatures scrolled across the screen. Most matched expectations for interstellar comets, frozen volatiles, organic fragments, cryogenic compounds. But one set of values burned through the noise. Ionized carbon monoxide, far hotter and more concentrated than what solar heating alone could produce. Carbon monoxide, glowing blue. A thought flickered. A hot internal engine would ionize gases exactly like that. I rubbed my forehead, feeling the weight of another taboo truth rising. Minutes later, another alert arrived from Chile. They had detected what appeared to be a rotating beacon, a rhythmic modulation in the light curve, faint but consistent over 4 cycles. Not a blinking pattern, not Morse code, nothing communicative, but rotation with timing precision. No comet spins with that kind of uniformity after a violent solar pass, unless the spin was controlled. I forwarded the files to NASA. The reply came faster than I expected. We believe this is a momentary artifact caused by equipment calibration drift. We'll recheck. They dismissed the possibility before even analyzing it. Fear disguised as professionalism. Over the next 24 hours, my inbox flooded with inquiries. Journalists, researchers, skeptics, enthusiasts. Most wanted certainty, but the universe rarely offers that luxury. What it gives us instead is the privilege of wonder, of confronting a frontier our ancestors could barely imagine. But some messages carried another tone. Unease, worry, the sinking realization that if 3I/ATLAS was more than rock and ice, humanity might be standing in the early shadows of a revelation we were not prepared to face. At dawn, I drove to the Harvard-Smithsonian Observatory. The streets empty, washed in cold blue light that mirrored the object itself. I found Dr. Elena Ruiz, one of the most level-headed astronomers I know, staring at a data set so intently she didn't hear me enter. Elena? She jumped slightly. Avi, look at this. She pulled up an animation showing 3I/ATLAS's mass loss model. The projected mass drop for a natural comet at this distance and temperature was modest, but the actual mass loss curve plunged like a cliff. Nearly 10% of its total mass had disappeared in a single month. That would produce a massive halo of vapor, Elena said. We should see it expanding like a cloud. But we don't. No. She hesitated. It's losing mass, but not in a natural way. What do you think is happening? She swallowed. It's venting, like pressure release, like something shedding weight on purpose. We stood in silence, the monitor's blue light reflected in our eyes. Then she voiced the question neither of us wanted to say aloud. Avi, what if it's discarding something? Fuel. Material it doesn't need? I exhaled slowly. Then it's not a comet. Another data burst arrived from JPL. 3 ultra-fine corrections in the trajectory recorded within a 1-hour window. Micro-adjustments so small no natural body could produce them. Maneuvers. The world outside continued spinning. Children going to school, adults pouring coffee, airplanes crossing continents, while in the cosmic black, an object from another star performed course corrections with surgical precision. Later that afternoon, the first public debate ignited. Interviews, podcasts, news segments, NASA repeated their stance. No evidence of artificial origin, but the cracks were widening. The public saw the blue glow. They saw the anti-tail. They saw the sudden acceleration, the slingshot path, the anomalies stacking like dominoes. A reporter asked on live television, Professor Loeb, do you believe 3IATLAS is an extraterrestrial probe? I looked into the camera and answered with the honesty science demands. I believe it is acting as if it is guided. The backlash was immediate. Skeptic panels, ridicule on social media, cautious academic distance, but beneath the noise, there was something else. Curiosity, fear, and a dawning awareness that maybe humanity had just witnessed something extraordinary. That night, I returned home exhausted. I opened the curtains and stared at the sky, trying to imagine the cold, silent path of 3I/ATLAS as it carved its way deeper into the solar system. It moved with purpose, too subtle to be threatening, too elegant to be coincidence. A question pulsed in my mind, constant as a heartbeat. If it came this far, where is it going next? And more importantly, why? In the days that followed, 3I/ATLAS drifted farther from the sun, climbing steadily toward the outer solar system. And yet, the farther it moved, the more deliberate its behavior appeared. Subtle arcs, fractional pulses of acceleration, glints of blue that flared and softened like a distant heartbeat. It was as if the object wanted to vanish without leaving a trail, but physics betrayed its intent in every anomaly it failed to hide. At the Harvard Observatory, we watched its data streams thinning as its distance increased. Signals blurred into static. Light curves stretched into low-resolution flickers. Soon we would lose it completely. That inevitability hung over the room like a quiet sentence. But before the veil closed, the universe handed us one final clue. A fresh data pulse burst across the monitors, unexpected, sharp, and unmistakably structured. Not a message, not communication, nothing so naive or cinematic. It was something more primitive and yet more revealing. A thermal bloom, a sudden burst of heat that expanded around the object in a perfectly spherical wave. Natural bodies don't radiate heat in symmetry. Jets produce chaotic patterns, but this was uniform, a controlled ignition. The wave faded after 6 seconds, leaving the object dimmer but cleaner in its trajectory. A correction burn, a final adjustment before its exit. It was leaving us on purpose. I glanced around the room. The younger researchers stared in awe, while the older ones looked away, refusing to let astonishment disrupt decades of rigid certainty. One whispered, "Dear God." Another, "We'll never convince NASA with this." Another voice trembled, "We shouldn't try. People aren't ready." The fear, finally spoken aloud. By evening, the news networks had caught wind of the anomaly, thermal bursts, unusual signals, unnatural corrections. NASA issued another calm statement about sublimation events, but the public sensed the cracks widening. Conspiracy forums erupted, military analysts weighed in, philosophers debated the meaning of a silent visitor. I stayed mostly quiet, answering only when pressed, but inside, The truth swelled like a rising tide. We were not witnessing nature. We were witnessing discretion. Whatever 3I/ATLAS was, it behaved like something that didn't want to be found. On the fourth night, as the object slipped past the orbit of Jupiter, I stood on the rooftop of the Harvard Science Building. The air was sharp with winter, the stars trembling against the black. Somewhere out there, a faint blue ember was gliding toward the cosmic dark, carrying secrets we might never decode. My phone buzzed. Dr. Elena Ruiz. "I think I know what the thermal bloom was," she said quietly. "A shielding mechanism. It heated the outer surface to shed accumulated dust and debris, to hide its signature, to erase evidence." We stood in silence across the phone line. No scientist wants to admit an object is acting with intention. Intention implies intelligence. Intelligence implies origin. And origin terrifies people more than any comet ever could. I whispered, "It's cleaning its tracks." "It's leaving," she replied, "and it doesn't want to be followed." A cold wind cut across the rooftop. The sky above me widened. Every star felt suddenly closer, as if listening. For the rest of the week, the anomaly reports slowed. The object dimmed. Its motion grew steadier, smoother, as if settling into a long, graceful outbound trajectory. Then, one morning, the final data drop arrived. A faint blip, a last echo. After that, nothing. 3I/ATLAS was gone. In the silence that followed, the scientific community fractured. Some clung to natural explanations with an almost religious fervor. Others admitted uncertainty. A few dared to speculate openly. And beyond academia, the whispers continued. Ordinary people, sensing that something monumental had passed by unnoticed, like a shadow brushing the edge of human consciousness. I returned to my office and sat before the darkened screens. The data traces felt like the pages of a mystery whose last chapter had been torn out. Still, one truth remained unshakable. The object behaved as if guided, intelligent, purposeful, intentional. Was it observing us, testing us, passing through by coincidence? Or was it simply following its own mission, indifferent to the species watching from a small blue world? Questions without answers. A cosmic riddle sealed behind silence. That evening, I stepped outside into the quiet Cambridge night. Students walked by, laughing, unaware that something extraordinary had slipped through our solar system like a ghost. I looked toward the western sky, imagining the faint trail of 3I/ATLAS disappearing into the black, accelerating toward whatever destination awaited it. If it truly was a probe, then it now carried fresh data, measurements of our star, scans of our planets, glimpses of our signals bleeding into space. And perhaps somewhere light years away, something would receive that data and learn we exist. I let the thought settle, neither afraid nor comforted, just aware that the universe may be far more populated than we once believed, aware that silence does not equal solitude, aware that our ignorance of the cosmic neighborhood doesn't make it empty, only unexplored. The night wind whispered across the courtyard. Somewhere above, the stars continued their quiet watch. 3I/ATLAS had come. It had maneuvered. It had revealed the shape of a question humanity has avoided asking for too long, and then, just as silently, it left, leaving us with wonder, with fear, with possibility, and with the undeniable truth that we had witnessed something that did not behave like nature, something that behaved like a visitor,